Okay, so moving on to part B of question 4, find the value of P and the value of Q. So our resultant force can be found by adding together our three forces. So we've got one force which is Pi plus 2J, we've got another force which is 3 minus Q, and we've got the last force which is Qi and 2Pj. So if we add those all together, that gives us P plus 3 plus Q as our I component, 2 minus Q plus 2P as our J component. And we're told that produces an acceleration of this. So if we use our F equals ma equation, we've just worked out our overall resultant force vector, which is this. And we know that's equal to the mass of the particle, which we are told is 2 kilograms, multiplied by the acceleration vector, which we were given, which is 1I and minus 3J. So if we just look at our I components, this should be equal to 2 times 1. So we can say that P plus 3 plus Q equals 2. And similarly, if we look at the J components, this should be equal to 2 times minus 3. So we can say that 2 minus Q plus 2P equals minus 6. So we've got a pair of simultaneous equations there. So what I'd probably do is neaten up the first one and say P plus Q is minus 1. And then the second one, if we subtract 2 from both sides, we can say that 2P minus Q is equal to minus 8. And then what we could do, we can add these two together to eliminate the Q's. So we end up with 3P equals minus 9. P therefore is minus 3. And then substitute that, say, back into here. If P is minus 3, then if we add 3 to both sides, that means that Q is equal to plus 2.